Hi guys, and now we are entering into the statistics part where we'll be discussing about the position of data, right? The central position of data, right? Central position of data carries a lot of significance in any data that you're trying to analyze because you're trying to find out what on an average circumstances is happening, right? Which gives you the inference that okay, this is what usually happens, right? That is the question that you're trying to answer, right? Now, how do you find the central position of data? And there are a lot of theories which have been developed over central position of data based on the observations or the calculations that previous scientists or mathematicians have done over finding the central position of data, right? So a lot of things, right, including dispersion, is based on the central position of data, right? Because you're trying to find out how much is it dispersed from the center of the data, right? So let's get started with I'll just briefly discuss initially what is statistics, right? So statistics, in my opinion, as opposed to what is written in the slide, of course, is that the difference between statistics and mathematics is mathematics you're trying to calculate a value, right? Let's say you're trying to calculate time, the present value, the rate, right? Whereas what statistics is doing is statistics is trying to summarize your findings, right? And when you summarize your findings, you tend to draw some conclusions, right? Based, if I presented you, let's say, with stock market data, and I gave you the stock price of Yes Bank for, let's say, 21st March, right? That is a data, right? But if I present this across, let's say, about 365 days, and I do some calculation on it, and then I try to give you some summarization, that will make some meaning, right? So that is the difference between mathematics and statistics. So statistics is a form of summarization, right? In a nutshell, okay? That is just my explanation in a very very simple, you can say, and I'm also trying to summarize based on my experience, okay? Now, uh, again, statistics is divided into two parts. One is what we call as a descriptive statistics, and the other part we call it as inferential statistics, right? Now, descriptive statistics includes calculations, majorly calculations, like mean, median, mode, right? Trying to find out the center position of data. Again, find out dispersion, wherein you are saying that from this central position of data, what is the average distance of all of these observations that are happening, right, in the form of range, variance, and standard deviation. Then you're also talking about the shape of these distributions, right? The is the distribution shaped very unique, in the sense, is does it follow a certain pattern, like is it a bell shaped shape, right? What is the height of that shape? What is the tilt of that shape, right? So those are the measures of shape. All are used finally to infer something, to make some conclusions, right? It's not just because the reason why I'm talking about all of this is so that you understand why we are doing it, and get a perspective of how it is actually used. That's the reason why we are using templates for every uh, you know uh, every concept that we're trying to learn. We are not trying to learn theory, right? So there's also an example given here. For example, the given population density, median age, distribution by religion, literacy rate. All of these are summarization, right? It does not talk about one single data point, but it talks about a large data set, and you're trying to summarize your findings, right? Descriptive statistics, I already told you what it is, right? Inferential statistics is trying to talk about theories which you can take that sample data and conclude on a population, right? For example, if you were talking about a 1 year data set or a series of stock market performance, you could use this sample to calculate certain values and then create a hypothesis on what can happen in the future. So that is where forecasting comes into picture using statistics. So that is only possible with statistics, right? That's the reason why it's so important, right? A simple difference between what is data series and data set. So if I give you, let's say, stock price data only, right? Let's say I talk about only closing price of Nifty 50 index, right? So that's a data series, right? So data series has just one particular characteristic of data, right? Whereas data set will include not just the closing price, it will have opening price, it will have closing price, it will have volume, it will have date. So data is set is a combination of multiple characteristics of data, right? Of course the definition you can read it in the presentation, but this is just my experienced, I mean, I'm just talking out of experience what I feel is data series versus data set, right? Now talking about mean. Okay, now there are multiple ways to calculate the central position of data, right? And again, very logical. If you think, if you forget about this formula that is written out here, and if you just observe things, right? Like just the way I was talking about in financial mathematics class, right? That if you try to observe what is happening, this formula automatically comes, right? Because this formula also was created by some mathematician who observed something and then tried to summarize what he's tried. All formulas do is try to summarize a certain pattern, right? I will come to calculation of this in a while. But what mean is trying to do, a simple arithmetic mean, right? This is also called as arithmetic mean, is to just add up all the values and divided by the number of observations, right? It's just like, you know, you would usually do this calculation if you were trying to, find out what, you know is the average of a certain value, right? In just one-on-one, regular conversations that you might have in your office or in your college, right? When you're trying to say that, okay, what is the average marks of students we did in this last semester, right? So you would just say that, okay, let's add up all the scores and then just divide it by uh, the number of people who actually gave the exam, right? So that would give, okay, that is where the data is centrally located, right? Second is, if you went if you were you had people who have, let's say, high cholesterol in your family, right? And you would go for a test to the doctor, and you would say that, okay, I want to do my HDL, and let me find out where, how's my various vitals like. So the observation would come up, right? And what they usually do in that report is also, if you look at this medical report, there's a range, right? And now these average ranges have been calculated based on the observations of so many patients, right? And they just add up all of these scores and just divide by the number of people uh, you know who have taken that test, and that tends to become the central position of the data. So that means, if everybody is, let's say, sick, then the average would be possibly just telling you that this is the central position of data, but not necessarily it means that you are healthy, right? So you have to be careful with, your language that you're using, right? So, and you have to be careful with your sample, because if you're taking the averages of all the people who are unhealthy, then your mean, and if you try to compare your statistics with the unhealthy person, then you are making wrong conclusions. Median, on the other hand, does not talk about the central position of data in the sense of uh, adding up values, right? So it's not arithmetic calculation, right? It's rather trying to find a location where the data is centered. So, in the same medical example, if we were to take, let's say, blood pressure readings of, let's say, patients, right? And we would take, let's say, 100 samples, right? In average, what we would do is we just add up all these blood pressure numbers and then divide by the number of patients that we tested. Versus in median, what we would do is we would arrange the blood pressure readings from ascending to descending or from descending to ascending order, and then try to find the middle location of it, right? So in this process, what we are doing is, we are trying to just find the location compared to doing algebra, right? So, uh, and the data could be very different, because since you're doing 100 observations, right? Uh, there is lesser chances that the person who's very weak, who has a very low blood pressure, versus a person who eats junk, who has very high blood pressure, would affect your central location of the data, right? So always remember, whenever you are using median, mean or mode or any other method, you have to always understand that you're just finding the average location, not necessarily this is the conclusion that this is what is going to happen all the time. It's just saying that this is the central location of data, right? Finally, mode is saying that let's not even talking about arithmetic addition, let's not even talk about the location, let's just find the frequency, right? So if we were to take blood pressure recordings of different patients, then we would say that okay, 125 by 65 is the most occurred blood pressure reading. So that is the central location of data. Now this might not work properly in stock market data because every price is unique. So in the fraction level, right, in the decimal level, so you would not be able to actually theoretically calculate mode, but the way to calculate mode could be to just round off to the nearest value, right? And then maybe you were able to get the mode, right? So these are three different ways of finding or you know three different ways of calculating the central location. And now, as with everything, let's jump into the template. All right, so we are with our template, and now what I've done is I've tried to take the main data set, which is your daily prices between 2005 to 2021, which is a long data series, and I've tried to create years so that we are dealing with a slightly smaller sample so that we can get the point across. And I've got the various closing prices on the same, almost the same date every year. Okay, so 12th 7 2019 has been repeated, right? And what I try to do is now, obviously, when we are dealing with stock market prices, we want to talk about returns rather than the price. You don't want to calculate. I mean, if I calculate the central location of the price, it's not really going to give me any information, right? But since the unit has to be carefully observed, right? So because the unit which will make you or give you more reference or inference is the returns, the percentage change, the returns that the customer is making, right? So let's find out the yearly returns, right? So I've just quickly calculated. I hope now you are as fast as me in calculating the percentage change. So I'm not going to go very slow on that because you could very well slow the video and watch it again. But I don't do this in the class, so don't worry. So YOY returns is what I found out for every year how much returns has Yes Bank made for its shareholders. Right now, I am interested in what is the distance, what is the central location of the data. Right now, remember we discussed mean, uh, median, and then we discussed mode. So mode we are not going to discuss because mode is not applicable for stock market returns, but we're going to discuss mean and median. Okay, so mean is simple, it's just the addition of these values and number of observations, right? So the observations obviously is 15, right? So mean would be calculated as just add up all of these values. You could use a function for this, but still doing it manually to get the concept in place. And we can just count the number of observations instead of just writing 15. We'll just use the count function, and there you go. And I'll just reduce the decimal places so that it becomes visible. So the average, the arithmetic mean is 17.66, right? So it tells us that okay, the data is centered at 17.66, right? The yearly returns. So that's the average returns, right? Now remember, mean does not have to be zero, okay? In case you have any such perceptions, and people tend to have that okay, mean has to be in the middle, so it's zero. Not necessary. Okay. Now, if we have to calculate median, we'll have to rearrange this data, okay, in an ascending or a descending order. Okay. So what I'm going to do is I'm going to select this data and I'm going to put a filter out right here. Just let's say I'll put a new header here. Okay. So I'm going to select this and put a filter, and I'm going to just rearrange this from smallest to largest or largest to smallest, doesn't matter. Okay. Oops. Oh, I think the calculation is there, that's why it is not happening. Let me just paste these values and so let's do just okay. So I have removed the formula, that's the reason why it's not working. And this calculation will not change because the values, it doesn't matter for arithmetic mean whether it's ascending, descending, it really doesn't matter, right? Now we are interested in finding the central location, and it's actually as simple as we say central location, right? So if you see, it's odd number of observation, 15, right? So if I were to say that you had to split 15 into two halves and tell me what is the center of 15, right? What would you do, right? So you would say that okay, let me, so if let's say I'm trying to split 15, right, into two parts, and I'm trying to find the center location, I can keep 7 on both the sides, and there would be one observation which is at the center, right? Literally center, right? So let's count. Okay, let me just put in another column, and let me just change this formatting to number. All right, so 1 all the way up till 15, right? So if you see out here, and these are just observations, okay, don't get confused. So if you see, 7 is on the other side and 7 is on the other side, and this is the median, right? And if you were to use a formula also, you would get the same answer. So let's use the formula, but in the formula you really don't have to arrange the data in certain order, right? So there you go, 12.36, and that's exactly what it has found out, right? So you go do this manually as well. Now what happens in case of, this is in case of observation is odd. If the observation is even, that would pose a challenge, right? So if let's say, okay, I'm gonna again put another column out here so to explain even. So let's say we had one more observation just for the sake of this discussion. All right, and let me keep it so that I don't have to again rearrange this data. So I'll keep it minus, let's say 85, so that it's already rearranged properly. And now instead of having 50, now we have 16 observation, right? So in that case, how do you calculate median? Is very simple, manually. Okay, first is to say that okay, that means if I keep 7 on one side, okay, so let me just put in the number format so that I can put it out here. And there was 16, right? 16 observation, out here 15 observations. So it's not going to work out the same way, of course, because we have even observations, right? There you go. So I cannot say that we have 7. So if I were to do 7 on this side, and if I were to do, let's say, about 7 on this side, where is 7? Yeah, 7 on this side. So that means now I have 2 locations instead of 1, right? So in that case, what do I do? It's as simple as you, if you were to use common sense, you would have done this, right? Instead, what you would have done is, okay, since we have 2, let's just average this out. Okay, so in this case, median would be calculated as the 2 observation, which is 10 and plus 2.36, and just the simple average of it, or the arithmetic mean of it, divided by 2. So that would give you the median in case of even number of observation. And if you were to calculate this using function, it would hopefully give you the same answer. Yes, right? So see, exactly the same answer. So it's as simple as that, right? Just finding the average of the 2 locations rather than 1 location. So that's what happens when you try to simplify, just try to observe what is happening, and then you could summarize using a formula, right? So if I were to summarize the mean formula, I would write something like this. Obviously the summation sign is, let me see if I can actually do that. Yes, I think we should have the, okay, I think we'll not waste time there. So I'm just gonna write summation, right? So just ignore the sign out here. think that that's the complicated summation sign. And I would say that okay, summation from x to y, right? Because we are adding up numbers from here till here, right? So how do I signify that? So maybe I say I is equal to, so I is equal to 1, and I would probably put a line to that, and I would say till n, right? So I till n is the number of observations that I'm doing, or I could just keep it here to keep things very simple, right? And then I want to say that you have to divide that by the number of observation. So I would just divide that by number of, or by n, right? So that is what the mean calculation would look like based on a formula I just try to funnily recreate without using the symbols. So don't worry too much about symbols, right? If you just use data and try to apply it, things tend to become simpler, right? So that was median, guys. Mean and median, central location of data. And I'll see you again in the next lecture.